Section 7.3, Trigonometric integrals. In this section, we will cover integrating products of powers of sine x and cosine x, the reduction formulas, and integrating products of powers of the tangent x and secant x. Integrating products of powers of sine x and cosine x, we consider the integral of the form, the integral of sine to the power m of x multiplied by the cosine to the power n of the x with respect to x, where m and n greater than or equal to 0. Case 1, where the degree of the sine is an odd number. Step 1, we're going to strip one sine factor out. Step 2, convert the rest to the cosine term using the identity sine square x equals 1 minus cosine square x. And the last step, let u be cosine x and finish the rest of the problem using the U-sub technique. Case 2, where n is odd or the degree of the cosine is an odd number. This time, the step 1, we're going to strip one cosine out, and step 2, convert the rest to the sine term using the identity cosine square x equals 1 minus sine square x. And step number 3, let u be sine of x. Again, finish the rest of the problem using the U-sub technique. Case number 3, where both degrees are odd. For this particular case, you can use either case 1 or case 2. The answer will come out as a different form, but they are equivalent in the value. For the last case or case number 4, where both powers are an even number, this time we're going to use the half angle formula. Cosine square x equals 1 plus cosine 2x divided by 2, or sine square x equals 1 minus cosine 2x all divided by 2. Let's look at the first example. The integral of sine square x multiplied by cosine to the third x. The power of the cosine is an odd number, so we're going to target the cosine to the third power of the x. Step 1, strip cosine out. So integral sine square x multiplied by the cosine power 2 multiplied by the cosine power 1 with respect to x. Step number 2, we convert the rest to the sine term. That means the cosine square here will be replaced with the sine term, which is 1 minus sine square x, and then multiply by the one that we just stripped out. And then step 3, we are going to let u be sine x. As u equals sine x, therefore, the du or the differential u is cosine x dx. Now, we use the U-sub technique to complete the problem. As u equals sine x, the first term is going to be u squared, and then multiplied by 1 minus u squared. The cosine x dx now is replaced by the du term. And now we are dealing with the problem involving u and du, or integral u to the second minus u to the fourth with respect to u. Using the power rule, we get 1 over 3 u to the third minus 1 over 5 u to the fifth, and then plus c. Finish up the problem, replacing u back with the sine x term. We have 1 over 3 sine to the power 3x minus 1 over 5 sine to the fifth x, and then plus c as a constant of integration. Next example, the integral of sine to the third x multiplied by cosine to the 3/2 x dx. This problem, the power of the sine is an odd number. We're going to go with the process for the case number 1, which is the power or the degree of the sine is an odd. Step 1, strip one sine out of the sine to the third. We have sine to the power 2 multiplied by sine to the first power, and then multiply by cosine to the 3/2 x dx. Step 2, convert the rest to the cosine term. Using the identity sine square equals 1 minus cosine square x. So the rest of the term here will be replaced with 1 minus cosine square x, and then multiply by the sine x that we strip out and multiply by cosine to the 3/2 x dx. Step number 3, let u be cosine x. U equals cosine x. The differential u is negative sine x dx, or negative du equals sine x dx. Now we're going to use the u sub technique. This problem becomes 1 minus u squared multiplied by u to the power 3/2, and the sine x and dx is negative du. And then simplify the integrand, becomes u to the second minus 1 multiplied by u to the 3/2 du by applying negative sign to the factor, to the parentheses, sorry. And then we distribute u to the power 3/2 to both terms to become like u to the power 7 over 2 minus u to the power 3 over 2. With respect to u, use the power rule to find the antiderivative. We have u to the power 9 over 2 multiplied by 2 over 9 minus u to the power 5 over 2 multiplied by 2 over 5 plus c. And replace u with the cosine x to get 2 over 9 multiplied by the cosine x to the power 9 over 2 minus 2 over 5 multiplied by cosine x to the power 5 over 2 and then plus c. We are going to change the rest of the cosine in terms of the sine. The identity that we have is cosine to the second power equals 1 minus sine to the second power. Therefore, we have to break it down from the power 4 as a product of the power 2 and the power 2. Now, each power 2 will be replaced with 1 minus sine square x. This time is 2x, sorry. Multiplied by 1 minus sine squared of the 2x and cosine multiplied by cosine of 2x dx. And next, we're going to let u be sine of 2x as a step number 3. The following part of this is the differential u. Du is cosine of 2x and multiplied by 2x becomes 2 cosine 2x dx as a differential u. That gives us 1/2 of the du equals cosine of 2x dx. Now we're going to replace the sine and the cosine with the u and du expression. We have the integral 1 minus u squared multiplied by 1 minus u squared multiplied by the 1/2 of the du. The product of 1 minus u squared and 1 minus u squared give us 1 minus 2 u squared plus u to the 4th. With the 1/2, we take it as a coefficient out front and with respect to u. And then we find the antiderivative with respect to the u. So integral of the 1 with respect to u is u minus 2 over 3 u to the 3rd plus 1 over 5 u to the 5th and then plus c. The last step, replace u with the sine of 2x to finish up the problem. So sine of 2x minus 2 over 3 sine of 2x to the power 3 plus 1 over 5 sine of 2x to the 5th and then plus c.